Section number 4, question 27. So the question tells us that we've got a function. That function in the xy plane is a line with negative slope. And then they ask which of the following Roman numerals must be true. So first things first, we need to know that a negatively sloped line looks like this. Okay, it's just sort of headed downhill. This is positive slope, this is zero slope, this is undefined slope, this here is negative slope. So that's the first thing we need to know. We also need to understand that notation like this, a and f of a, these are just xy coordinate points. The a is an x value. We know that because the a is in parentheses, and in function notation it is our x or input that is in parentheses. So this is an x value. This whole thing is a y value. So when we talk about a and f of a, we are really talking about an xy point where the x value equals a and the y value equals f of a. So when a goes into our function, we get an output. That output is f of a or y. So a comma f of a is just a point on the line on the xy plane. So we need to understand all of that to understand the notation that's in the Roman numerals here. So let's deal with Roman numeral 1, which is actually probably the trickiest of all three of these. So what I'm going to do is I'm going to draw an xy plane. There's my y-axis, there's my x-axis. I am then going to draw any old random negatively sloped line. So let me draw that line right there. I am going to abide by the if portion of Roman numeral 1. This is called the hypothesis. This part is called the conclusion. You don't really need to know that for this question, but the hypothesis here says that a is less than b. So what I'm going to do is I'm going to pick an a value, which again, I know that that a value is an x value and the b value is an x value because the a and the b are in parentheses there. So those are x values. So I'm going to pick an a value over here and a b value over here. Now keep in mind, the a doesn't have to be negative. The a value could actually be here. The b doesn't have to be positive. The b value could be over here. I'm just making sure that I'm satisfying that a is less than b. So the a x value has to be to the left of the b x value. So if I look at what is going on here at that a and that b value, I've got these 2 points. One point here where my x value is a, and one point here where my x value is b. So if I'm writing my coordinates, I know my x value there is a, and over here on this right hand point, I know that my x value there is b, and my y value is going to be f of a. That's what we said before. We've got an x value and a y value. So this y value right here, this is f of a, and again, that point, f of a, that's the y value. A, f of a, x, y. Now over here at b, we've got b, comma, f of b. Again, b goes in, f of b comes out, x is b, y is f of b. Well, we can see that f of a, which is up here, and f of b, which is down here, relate in that f of a has to be greater than, or at least in this case, is greater than f of b. But that relationship will be true for any negatively sloped line. If I take a negatively sloped line and I think of one x value here that is less than another x value here, right? This x value is to the left of this x value, so that first x value is less than the other. The y value that corresponds to that first x value will always be higher than the y value that corresponds to the second x value because the line is going down. It is decreasing. The y values are decreasing as x gets bigger. As you go from one x to the next x, the y values go down. That is always the case on a negatively sloped line. On a positively sloped line, it's different. On a positively sloped line, it is the case that as you go from one x value to another x value, the y values go up. You go from this y value here positively sloped line, when you go from a smaller to a larger x value, the y values go up. On a negatively sloped line, when you go from a smaller to a larger x value, the y values go down. So again, if I am at an A and then at a B, and that A is smaller than that B, then it will always be the case that f of A, the y value that corresponds to the first A or x value, will always be, f of A will always be greater, f of A will always be greater than f of B if A itself is less than B, because again we have a decreasing relationship. The y values are going down as the x values are going up. So Roman numeral 1 is always true. Roman numeral 1 really just describes a property of negatively sloped lines that is always true. Now Roman numerals 2 and 3, I suppose the tricky thing about Roman numerals 2 and 3 is understanding that the question has only given you information about slope. The question has not given you any information about y-intercept. So I'm going to look at Roman numeral 2 right here. So there is Roman numeral 2 along with some other stuff. Let me get rid of that other stuff. So this says if A is less than 0, then f of A is greater than 0. Well, if you are going really fast and you're being maybe a little bit haphazard about this and you just draw what you think is a normal negatively sloped line, maybe you draw this one, maybe even draw one that goes right through the origin. If A is less than 0, well remember A is an x value. So x less than 0 means we're over here to the left of the y-axis, right? If A is less than 0, I have to be choosing an x value, an A value that is negative, so again to the left of the y-axis. And if I look at where that A value hits my line, it is true that my f of A is positive there. My f of A is greater than 0. In other words, I have satisfied the if part by making A less than 0, and the then part is also satisfied. So if you choose a line that looks like the one that I've chosen here, you may think that Roman numeral 2 has to be true. But I don't have to choose a line that looks like the one here. I could choose this negatively sloped line. And on that negatively sloped line, if I choose this A value right here, which is negative, it is to the that A value, that x value is to the left of the y-axis, well, the y value that I get, the f of A value, which is my y value, is actually now down here below the x-axis. That f of A value is negative. And therefore, what I've just shown here is that when A is less than 0, right, A is negative, I am getting an f of A that is actually less than 0. So this scenario shows that Roman numeral 2 doesn't have to be true. It can be true, it's true over here, but it's not true over here. In other words, Roman numeral 2 depends on the negatively sloped line that I choose. If I choose this line, Roman numeral 2 is true. If I choose this line, Roman numeral 2 is not necessarily true. And again, I could choose this line here, I could choose this line here, I could choose this line here. As long as my line is negatively sloped, I am abiding by the question, and I do see here that there are examples in which Roman numeral 2 will not be true. So Roman numeral 2 does not have to be true all the time. Now what about Roman numeral 3? Roman numeral 3, again, let me copy this, bring this down. Let me get rid of some of this messy stuff here. Okay, so Roman numeral 3 says if A is greater than 0, then f of A is less than 0. So again, that's saying, should have done this before, that's saying if x is greater than 0, then y is less than 0. By the way, let me add that up here. X is less than 0, y is greater than 0. And then this one, what we'll say is if x1, so let's say this is x1, is less than x2, then f of x1 is greater than f of x2. I apologize, I should have done that from the beginning. It might have made everything a little bit easier to see, but we'll do it on Roman numeral 3, and if you need to, you can go back to see how it would apply to Roman numerals 2 and 1. So again, all Roman numeral 3 is saying if x is greater than 0, then y is less than 0. Well, again, depending on the line I choose, that might be true. For instance, if I choose the line that, a line that has a negative slope and goes right through the origin, it will be true then when I choose a positive x value. Okay, so I'm making it a, that's the notation in the question, but it's really just an x value, and I look at where that x value would be on the line, I do see that my f of a, which is down here, my y value, is negative. So for this particular line, Roman numeral 3 is true. But again, I don't need to pick that particular line. I don't need my line to have a y-intercept of 0. I could have a negatively sloped line that looks like that. And now, if I choose a positive a value, right, an x value or a value that is greater than 0, now I am getting a y value, or f of a value, that is positive. My f of a here is positive. So what I have here is I have a positive a value and a positive f of a value, that's a positive x and a positive y, and therefore this right here, that's not true. My f of a is not less than 0. My f of a is actually greater than 0. So again, Roman numerals 2 and 3 depend upon the line that you decide to use. As long as the line is negatively sloped, you can use whatever negatively sloped line you want. And the problem is that, yes, in some cases, depending upon the line that you choose, Roman numerals 2 and 3 might look to be true, but Roman numerals 2 and 3 don't have to be true. If we use different lines, we can see that we can actually show that we can make, in Roman numeral 2, we can make a less than 0, and we can actually get f of a to be less than 0. That's what we showed here. And in Roman numeral 3, we can make a greater than 0, and we can actually get f of a to be greater than 0, which means that f of a is less than 0. It doesn't always have to be true. So Roman numerals 2 and 3 can be true, but they are not necessarily true. They don't always have to be true. And on a question that says, which of the following must be true, we need to pick only those Roman numerals or only those answers that are always, always true, no matter what conditions you choose to use.